Thank you for visiting my channel. Now, it was early in 2021. I took this course from UC Berkeley, a machine learning and prediction course from UC Berkeley. And coming out of that, I figured that I need to get some more hands-on to get a true sense of how these machine learning models work in real world. So that triggered me to go through multiple proof of concept model, POC model deployments. And this would be the first one that I deployed back in 2021, and I deployed two more for the remainder of the year. So I just wanted to share with you some of the insights and some of the steps that I needed to go through to train and deploy this model. So this is for cardiovascular disease prediction. Obviously, it's a classification-based model. The way I deployed this specific model was I went through the exercise of going through multiple classification algorithms and train and deploy with the same data set each and every single one of them. So I started out with logistic regression, and then I moved on to decision tree, random forest. I went through support vector machine, kernel SVM, naive Bayes, as well as k-nearest neighbor. So I went through the same exercise multiple times, just as you would expect from any data scientist or machine learning engineer to experiment with multiple models. And then I decided I'm going to take it to the next level, which was to apply gradient boosting on top of the classification model. So that's how I looked at XGBoost and CatBoost. And this specific model, this specific deploy, is based out of the CatBoost classification algorithm. So the reason I selected this one as opposed to any other ones that I experimented with was because I used accuracy as a primary measure to select the model. Now, just to let you know that it all depends on your specific use case, your specific scenario, and you may end up selecting another one. You may end up selecting naive Bayes or SVM or kernel SVM for that matter. So again, this is a gradient boosting CatBoost based model. And as far as the backend code, which I'm not going to touch on, I'm not going to show in this specific video, but I really hope that in a follow-up subsequent video, I'm just gonna go into the detail of some of the backend codes. But I can tell you that this was implemented using Python, TensorFlow Keras framework, and I use Flask for web deployment of the model once trained and developed. And to host in cloud, I looked at a few options there. I looked at Heroku, and then I ended up selecting Python Anywhere for this specific deploy. But again, it all depends on your situation. You may choose AWS or Azure or any one of those other cloud hosting platforms. Now, let's look at the model in action. So this model looks at key markers. It looks at age, gender, height, weight, blood pressure, which is a key marker for cardiovascular disease, cholesterol, glucose, smoking habits, alcohol consumption, as well as physical activity. Those are the things that this specific model takes data or input for, and it decides whether that specific situation for that specific patient results in cardiovascular disease prediction or not. So let's go through a couple of scenarios here. The first one I'm going to look at is a low risk scenario. So I'm going to pick a child, perhaps 10-year-old girl, and hoping that with everything else being equal, that the child should not be prone to cardiovascular disease. So let's go through that exercise now. So the age, I decided on 10 years. So because it's asking for days, so I'm just going to say 3,650 days. I'm going to select female for gender. Height, I do have a chart here. I looked at average height for a 10-year-old. We are looking at about 138, 139 centimeters. That's what I'm going to use here, 139. For weight, again, looking at that same chart, I think the average weight for a 10-year-old in North America is about 31, 32 kgs. So I'm just going to take the average here. Now the high blood pressure, I'm just going to go with 120. Low blood pressure, I'm just going to leave it to more of the average, which is around, I think it's around 80. Cholesterol, I'm just going to say it's normal. Glucose is a drop down. I'm just going to say normal. Now, smoking habits, I'm going to say non-smoker and do not consume any alcohol. Now, in terms of activity, I would hope that a 10-year-old is quite active, so I'm just going to select active. So this is my low-risk scenario, and I'm hoping with the data that I provided as input to the model, I'm hoping that this specific situation should be a low risk for cardiovascular disease. So let's see what the model has to say. So just click on that button here. All right, so just as I expected, it's going to be a no cardiovascular disease prediction by the model. Not only that, it also came back with a 1% probability of cardiovascular disease, which is very unlikely that there is a cardiovascular disease for this specific case. So that's the low risk scenario, and that's how the model actually analyzes the data and comes back with this result. Now let's look at a high risk scenario. So here I'm talking about a 60-year-old man, perhaps. So I'm just going to bring up my calculator here, and let's look at 60 times 365 days. We are looking at about 22,000 days. So let's just plug in 22,000 for days. Gender, I'm just going to say male this time. Now I do have the average height and weight for North American male, 60-year-old male. So I'm just going to have to bring it up here. Okay, so we are looking at about, for height, we are looking at about 178 centimeters. And for weight, because I selected this range, 60 years of age, we are looking at about 79. So 178 and 79 kgs. I think it's on kg. Yeah, it is on kg. So that's good. Kilograms, 178 and 79. So going back to our model here. So 178 centimeters and about 79 kgs. Now, just to make things a bit more interesting, I'm just gonna change that to maybe a little higher of a weight, maybe go over 85 kgs. So for blood pressure, I'm just gonna select a little high too, maybe go around 200. As well, for the low end, I'm just gonna go with 90. Now for cholesterol, I'm just gonna say it's above normal. Glucose, I can say above normal as well. The person here is a smoker, consumes alcohol, and quite inactive. So I'm hoping with this type of situation that the model is going to come back and detect a cardiovascular disease for this specific patient. So let's just look at that. And just as we thought, this specific patient, this specific test case is prone for cardiovascular disease, and the odds of cardiovascular disease is about 95%. So that's how this model works, and I hope you get a sense of how some of these models work. Again, I'm truly hoping that I can share the backend code and go through step by step the training as well as the deployment. I want to go through that and create another video for that, but I'm just going to leave it at that for now, and I hope to see you soon. Thank you.